Welcome to the ADCO Learning from Incidents series, Well Control and Blowout Prevention. We will be sharing with you some information on well control during drilling, the various systems put in place to control a well and prevent a blowout incident from occurring. We will also review the main reasons behind some of ADCO's well control incidents which were handled successfully. Prior to the preparation of the drilling program, the asset development team submits the final well prognosis to the drilling team. The well prognosis is initiated by the petroleum engineer. The reservoir engineer then makes a planning overview and provides the required formation pressures and temperatures. Then the following data is completed: geodetic data, conceptual data, geological data, reservoir data, geophysical data, and petrophysical data. Once all the data is entered, the well prognosis will be approved by the Reservoir Operations Asset Team Leader and will be published in ADCO system. Let's begin by explaining well control. While drilling, it is essential to perform activities in a safe way, which will prevent uncontrolled flow of formation fluids and gases from the reservoir to the wellbore and surface surroundings. This is called well control. This includes measures, practices, procedures, and equipment, workover and completion, as well as the installation, repair, maintenance and operation of surface well control equipment. It also consists of well control barriers, which are divided into two groups: primary and secondary barriers. The primary well control barrier is the fluid column hydrostatic pressure, referred to as well bore pressure, that provides overbalance against the formation pressure. This column must be monitored and maintained during drilling and tripping to prevent formation fluids from entering into the wellbore. During drilling, if the fluid column is not maintained with adequate mud density, making the formation pressure more than the hydrostatic pressure, formation fluids will find a way into the wellbore and a kick will occur. In this case, the well must be secured and killed. There are other cases when a kick can occur. Let's review some of them. While tripping, if there is a failure to keep the hole full of mud to maintain adequate hydrostatic head, then the hydrostatic pressure will be less than the formation pressure, inducing a kick. Swabbing while pulling out of a hole too fast can produce a suction effect, resulting in a decrease in the bottom hole pressure large enough to allow formation fluids to enter the wellbore, creating a kick. When drilling takes place too fast and into depleted reservoirs without proper reinforcement, it can lead to cracking in the walls and thus losing fluids into the formation, inducing a kick. Once a kick is detected, The secondary well control barrier, blowout preventer, BOP, must be activated immediately by the driller to secure and shut the well for killing operations. This is done by closing the BOP using one of the BOP control panels, one situated on the rig floor and the second situated in the CUMI unit. The driller will shut in the blowout preventer to stop the flow of formation fluids out of the wellbore. Then he will activate the alarm and notify ADCO drilling supervisor and rig manager. Meanwhile, at the rig site, the on-scene commander, ADCO drilling supervisor, will notify Abu Dhabi telecom operator and relevant assets control room and raise emergency Tier 1, which activates appropriate emergency response teams. Unnecessary crew will be evacuated to the nearest assembly point. The next step will be to monitor the shut-in drill pipe and the shut-in casing pressure gauges. The kick will be circulated out of the wellbore using the driller method first cycle by pumping drilling fluid downstream and getting returns from the annulus through the choke line to the choke manifold, and the pour buoy degasser and toxic gases will be flared. Once the kick is out, the well will be shut in. Then, the well will be killed with weighted mud by circulating the kill fluid until both the drill pipe and casing pressures reach zero. If all of the well control barriers failed, such as human barriers, BOP equipment barriers and system barriers, and the BOP leaked while circulating the kick-out, this could lead to uncontrolled flow of formation fluids and possibly a blowout. A blowout has massive catastrophic consequences, such as injuries and/or fatalities of personnel, release of toxic gases, pollution of the environment, asset damage, and damage of ADCO's image and reputation. ADCO strives to create a safe and incident-free working environment for all. This is why strong well control integrity assurance systems have been put in place. These include policies, standards, procedures, people competency, and equipment. Despite all of this, ADCO has experienced several well control incidents, which have been managed and controlled successfully, preventing a blowout. After sharing with you the primary and secondary well control barriers, we will now share with you some of the main causes behind ADCO's major well control incidents. No implementation of top 3 concept, plan, what if, competent people, incorrect formation pressure and drilling fluid weight, failure to implement management of change procedure whenever there are changes, failure to maintain BOP equipment. Learning outcomes from such incidents include: ensure every drilling operation begins with the discussion of the top 3 concept. Always use updated reservoir pressure data for defining drilling fluid weights. Make sure that any change in the drilling plan is governed by an approved management of change process. In case of well control, shut in the well immediately as per ADCO procedures and consult your supervisor. In conclusion, well control incidents must be avoided by all means, as they can lead to blowouts which have catastrophic impacts. At ADCO, we expect from all the well drilling stakeholders to ensure 100% full implementation of ADCO well control integrity assurance systems. It is the responsibility of all managers and supervisors, both in the office and at the rig site, to verify and enforce the full compliance of these systems to avoid catastrophic incidents from happening. With your continuous dedication, compliance to ADCO procedures, and your full commitment, we prevent well control incidents from happening in ADCO. Thank you for your attention.